please start the
Okay, sir.
session.
Thank you, sir. Once again, welcome back to all the participants. AICT Atal sponsored 6 days online faculty development program in the title of Next Generation Green Energy Powered Electric Vehicle and Renewable Energy Integration using Solar Microgrids, Polymeri Institute of Technology and Science. Now we are entering into session number 10 in the topic of battery charging technology for e-vehicle in the subject aspect of Dr. V. Sandeep Garu. Now, I will read out the bibliography of Sandeep Garu. Sir received PhD from Indian Institute of Technology, Delhi, 2013. He is currently working as Assistant Professor, Department of Electrical Engineering, and as well as Associate Dean, Industrial Collaboration and MOEs at National Institute of Technology, Andhra Pradesh. As well as Sir worked as a past head of the EEE Department, NIT AP, as well as Chair of PELS IASPS Joint Chapter. And IEEE Vizag Bay Section, he worked as Assistant Professor and Coordinator at the School of Engineering, Central University of Karnataka from 2013 to 2019. He received a project grants from DSIR, UGC, and IEEE. He is instrumental in establishing a common research and technology development hub in the renewable energy sector at NIT Andhra campus. As the project manager sponsored by the Department of Scientific and Industrial Research, the Ministry of DST, Government of India with a grant of 7.15 crores. He received a Gandhian in Technology Innovation Award in 2013, selected as among us the top 24s. Now, I will hand over the sessions to Dr. Sandeep Garu. Please take the session, sir. Sandeep, sir. Are you able to hear?
Yes, sir.
Please, sir.
Yeah. Thank you very much, everyone, and particularly the management and then EEE Department of Polymeri Institute of Technology, Hyderabad, for giving this wonderful opportunity to be part of your FDP program today. Yeah, so let me share my screen now. Yeah. Give me a second, just a sec.
No problem, sir. Take your own time, sir. Please.
Can you be able to hear my voice, please?
Oh, able to hear, sir. But previously slide will be shared.
Yes, yes.
Something
Now,
like that.
yes, I'll share now. Okay. Yeah. Okay. So thank you, everyone. I think my
No,
voice
okay.
is clear. Is it right? Yeah. Okay. So yeah, once again, thank you, and I welcome all the participants to the program also. So now, today then mainly, I'm discussing this topic, battery charging technologies for a vehicle. Of course, I will give you some kind of overview. Maybe if at all any repeating content, with reference to other previous speakers, please let me know, not a problem. But actually, I'm trying to give you some kind of unique way of, knowledge, on the electric vehicle technology. Maybe at the end of the, talk, maybe somebody can give feedback, so whether my talk is has some kind of new knowledge or something. Okay, so I'm happy to listen that. So let me go ahead this topic today. I think thank you very much again, Dr. Sharmanan, for giving this my introduction to this participants. Of course, this is my all accomplishment I have done with last 11 years and all. So basically, I used to talk on the renewable energy and then electric vehicle. Of course, higher education, innovation, and startups also, where my other focus of interest actually always when I try to interact with the students and faculty in engineering colleges and all. Yeah, these are all my achievements actually. So thank you very much for again for reading my biodata. Yeah. So this is expectation generally, any participants, if you attend this kind of FTP program, what would be benefit generally? So somebody will think it's not just only for certification purpose, but it's ideally it meant for some other purpose. Is it right? So then, I listed some of them here. So one is generally the participant, they look for, new content of knowledge. Is it right? So if you attend today's lecture, so definitely, okay. What happened? Yeah, let me see. Okay. Yeah. So they look for new also. So they also see kind of, other benefits beyond, new content of knowledge. Okay. So this is what, generally we expect actually. Okay. And one is, you search for some kind of project, if at all any young faculty or any mid-career, faculties are there, and even project students and then PG students, they'll also look for it. And one can explore for new directions for, their research work actually. So new topics and new areas, problem statements and all. If at all, if you're already into the research, and you can also discuss with the resource person how you can improve your research work, what kind of directions you can take further. And of course, you can also get to know the publication resources where you will get the materials and data collection also. And finally, it's a major benefit is, you're going to have a linkage with domain experts. Okay. So today, I became a known person to all the department. So you got to my affiliation, then email address and phone number easily. Is it right? So the networking will happen in your own professional area actually. And that's how, many times in the participants also, they reach out to me, including students and faculty after my talk. And then, they used to interact with us. And then, maybe students, they approach for internships, and faculty, for collaborations and all. So this is how the networking will happen actually, generally. So this is what, ideally, these are the expectation if you attend any FTP program. And I used to collect, a lot of information, knowledge, with reference to a lot of global developments happening, around us every day. And also, of course, it's inspired by, my teachers, students, and friends, because they used to give a lot of inputs to various sources and all. And obviously, it's a continuous learning and experience actually for every faculty member actually. Is it right? So this is what, I prepared this, today's lecture. And if you ask me, why electric vehicle, why it is, emerging, and, why government also giving, more focus and attention to this kind of, a new trend in transportation sector. And these are the reasons. Okay. So all of you aware of these reasons actually. And if you go and dig into these kind of reasons, definitely there we have solid, background. It is there. So why we are going this? So one is, depletion of, oil and gap, and between the, production usage in the next, next 20 years or 30 years. And then, definitely, its impact, global impact, and then economy. So every country economy, generally, it depends on, development happens on, economy. So now if you make it, complete energy independence, okay, if you don't import crude oil from any other countries or something, so mostly we are importing from UAE countries and that. So if you stop that, actually, if you completely energy sector, transportation sector, if you make it independent, so definitely our economy, will improve a lot. And of course, so we are directly also addressing the problems of climate change and global warming issue. And it will cause this less environmental impacts across their life cycle when they produce them and use them. And also we can directly reduce the noise pollution, and advantage with electric vehicle regenerative brake, and it's cheaper to run. And even if you want to travel 1 kilometer with your car, generally with petrol vehicle we used to spend like 5 rupees or 6 rupees actually. But in case of if you switch over to electric vehicle, definitely it come down to 1 rupee per 1 kilometer. And even bikes also, if you're spending like 2 rupees or 3 rupees per kilometer, it will come down to even 50 paisa per kilometer. That is what advantage with running in a cheap way, so with electric vehicle. But other side, electric vehicles has some kind of still some cons are there, and those are the challenges for the industries, particularly in the EV sector, as well as the faculty and students who are working in electric vehicle sector actually. And this is what I was talking about, gap between the usage and production that will happen definitely. And that's why we need to go with alternative fuel system, so where which will support our transportation in the country and or something. That's the reason, main reason we are going here. And recently this International Energy Agency, they made five recommendations to accelerate this EVs worldwide. So first one is we should maintain and adopt this support for the electric vehicle systems actually. And then we should immediately kickstart for heavy duty market also. Already technology is there very much proven for the light duty vehicles in case of 2-wheeler and 4-wheeler, but in case of heavy duty like buses and trucks. So I think nowadays some of the companies also in India also, they are also getting the market, and they release into this they get into this heavy duty market also, and successfully they launched many buses even in Andhra, Telangana, and Karnataka, and many other states in the North India also. And we need to promote and adopt emerging and developing countries, because earlier till now, if you see the statistics fully, it's occupied with developing countries only. So now our duty is to promote this this new technology in the emerging and developing country. And of course we need to expand the EV infrastructure in smart grid. Actually, if you promote EV vehicle selling only, that is not enough actually. We need to establish EV infrastructure. Otherwise, where do you get the charging? But to maintain that EV charging systems, conventional grid system will not support maybe further in the better way. So definitely we need to take help of smart grid actually. So that's where where how the smart grids and renewable energy and EVs can be integrated. These are a new interesting area to discuss it like always. And we can ensure and secure resilient and sustainable EV supply chain. So because if you buy any car, then there should be some kind of supply chain. Even you will see sometimes you will be surprised, there is a very strong market after the sales. Okay, so there's a market called after the sales market. So once it's sold, then service, maintenance, and spare parts, everything repair. So whatever those things, supply chain management system also should be required for the EVs actually. So right now conventional vehicle, so we have very good supply chain management system. Wherever we wanted to repair and then service part, it is easily available every town and city and but whereas in case of EV, we need to search it. So that we need to overcome that kind of challenge in the future. And look at the statistics of recent one. Actually, China is leading, and we have sold nearly 17 million vehicles are sold in 2024. And every out of 5 cars, 1 car is sold EV vehicle only worldwide. And that too, you can see that China is occupied this market. Is 60% market with them, and then European countries is 25%, and then United States is 10%. Where we are compared to them, actually we are negligible actually. But actually there is a one target for many of the developed countries. So every car sold to be EV vehicle by 2035. So that's what challenge they have taken actually, these developed countries. And so this is how you really, if you look at this evaluation of how it started in 2010 actually generally. And that time this Tesla was into the market. They released the first model, and then eventually different Nissan, so Hyundai, and a lot of other markets also getting into picture. So now we can see that rise in after the corona period 2020, 21, 22, 23. So this is what an exponential rise it took place in the EV market share. But you can see, so China is, as I said, 60% stock share with them only. And you can see a lot of registrations are happening, car registration sales in every year, so worldwide. And then you can see, and then obviously as discussed, China is leading in this actually. And you can see the car sales also. So we compare with the scenario like a 2010, 2025. So this is a scenario. So after the COVID period, it's an exponential rise it took place. And also many automobile companies, they come up with new solutions actually to how to increase the mileage. Okay, if a one single charge, so with version to version, actually they are trying to improve this. That's what in conventional vehicle also they give mileage. So mileage is 15 kilometers. Some vehicles is 20. Some vehicle they claim that 30, 28, something like. They used to improve the mileage for the vehicles every version. Similarly, in the EV also, they are trying to improve this battery technology and then try to see that more mileage should be given in terms of kilometer for a one single charge. And coming to the this charges also, right now we have publicly slow, I mean slow private slow charges are very much more actually. That's what private home charges are more one actually. So what we required general ideally public fast charges are required more, but that is less actually. So that's what where government also focusing now how to establish and where to establish these public fast charges when compared to private home charges actually. So that is what happening now. Everybody, if you, I think most of you are aware that if you're trying to buy a vehicle, then they are giving a kit, EV charger kit that will be installed in the home, and through that only you are trying to charge it, and then you go around within the within the town or city and all. So that is what you see that actually. And this is what the announcement from the automobile company makers actually. They have plans for this last decade actually. They are successfully executing them. And this is the EV, EV index. Okay, so these are the top companies. They are working in this electric vehicle, batteries, and automobile sector and all. So they are, hardly working towards to achieve their goals and all, as mentioned. And look at some of the basics now. Actually, maybe interesting to you actually. And sometimes basics also very strong. We make us very strong to understand the new technologies also. So one is here you can understand what are the elements in energy conversion technology, particularly automobile sector. So first is we'll have some kind of a primary energy source, okay, that you draw from the grid or solar, whatever it is, and then that energy we'll take, that is well. So we'll take it to tank. So that tank is maybe battery, some hydrogen, whatever, or fuel or something. So that tank, from that energy, it will come to wheels actually. We'll try to convert that chemical energy, and then we'll convert into finally it will convert into mechanical energy, right, to wheels. And then now that wheels will try to analyze the performance of the vehicle in terms of the miles. So this how vehicle to miles will come with in terms of driving cycle. Okay, so this how the energy conversion will take place in the conventional vehicle. And obviously we have many energy domains in the vehicle. Okay, chemical to thermal, mechanical to electrical, electrical to mechanical, mechanical, electrical to electrical, like this. So if you have more energy conversions are there in the vehicle, so then we then what will happen is our efficiency will come down, overall efficiency. So we can see that tank to wheel efficiency generally any kind of conventional vehicle. So you will have less than 50% efficiency. And because because every efficiency we need to take into consideration. Suppose if you take we fuel tank efficiency, and then engine efficiency, auxiliary systems, and clutch and gear, then if you take into consideration all the efficiencies, then overall efficiency tank to wheel efficiency less than 50%. And we can see that many technologies and statistics will tell us. So engine efficiency more than 60%. So this is what our major problem in the conventional vehicle. So engine itself having 60% losses when compared to a tank to wheel efficiency. Then how do you do that? And people have tried them mechanical engines particularly. So decades and decades they could not try to do much actually. Of course there are some kind of improvements with the gasoline engines and all, but they could not do much with this petrol fuel based engines actually. So then our immediate alternate scenario, we come up with the battery technologies actually. That's how the battery is getting a very popular battery driven vehicle. And even you can see that direct charging vehicle, battery vehicle with renewable energy, or hydrogen fuel cell based, or conventional vehicle. So obviously you'll continue when you take into all the consideration to this energy conversion. So you can say that battery driven vehicles has more overall efficiency when compared to even fuel cell or hydrogen actually. Conventional vehicles, sorry. And then what is the advantage with the regenerative braking? Yes, so when you try to apply the brake, then that braking energy will generally, it goes into heat form.
So that we can, we instead of going that heat, so we can try to tap up that energy. Okay, that kinetic energy will convert into mechanical energy. Mechanical energy will be converted into electrical, and finally we store into battery. So this is what advantage with the electric vehicle actually. So obviously we can also, try to address this, climate change and global warming issues. We can, if you go with, electric vehicle, so we can reduce nearly 50% of CO2 emissions. Plug-in vehicles 40%, hybrid vehicles 30% actually. And scenario, you can see that how the evolution will happen in the future actually, as per the IEA. And we are going to give a good competition with, even developed countries also. This is a good sign because our needs are there. So we have a lot of infrastructure is going on, and then definitely, we can, encourage this, electric vehicles in the Indian sector also. So there are some statistics will tell us, by 2040 we are going to give a tough competition because, as I said initially, so right now, United States market is 10% only, whereas China is 60%. We cannot, compare, we cannot compete with China immediately, but we can easily compete with the United States by 2040. This is what many government plans also will tell us actually. And these are types of the vehicle. Okay, many of you are aware of it, but let me give some kind of basics about it. So one is, hybrid. So where you have engine and then battery will be there, and never plug-in. That is also possible. There are some vehicles also there. And plug-in hybrid, where you have plug-in option. Since we have plug-in, we can accommodate more battery capacity. And then, last is fully electric vehicle, where you have battery and then motor only, and plug-in option is there. And this is, you can see that, hybrid electric vehicle, where you can see that, maybe fuel, gasoline or gas or petrol, diesel, whatever. And generally it will drive a combustion engine, and the engine will drive your mechanical axle of the wheel. And now when you apply the brake, that kinetic energy will convert into mechanical. So this, motor will, this machine will work as a generator. Through power electronics, you will store the energy here. And if you want to drive it using battery, so battery the source of energy. Through power electronics, you will, drive this motor, maybe induction motor or PMSM, okay, PMBLDC. Then you can drive, mechanical axle of the vehicle. So this is what here. So one observation you can make here. So the battery will get charged using regenerative braking only. There is no plug-in option here. And in this, so three types also there. So series, parallel, combined, hybrid. And you can find this series hybrid, where this fuel tank and then this setup, so completely in series connection. You can find in GM Volt. There's a patented and already commercialized long ago. And say a parallel hybrid vehicle, we can find Honda Insight vehicle. So that is also commercialized, and then it's available in the market. And then Toyota Prius vehicle, combined series and parallel, whichever you wanted to make a configuration, that is possible here. And plug-in hybrid, where you have, since you have plug-in option, then you can accommodate more battery capacity, and then, you can use same whatever previous hybrid, same this is also. But here plug-in is there, so that's why, we can accommodate more battery capacity. And this is a fully electric vehicle, then, we have more batteries, and then through power electronics you drive the motor, and then it will run. And this machine will work as a generator in the regenerative operating mode. And generally, so you can have a comparison of the, block diagrams of the conventional vehicle and then battery vehicle. It's easy, you can easily understand here. So battery will be there, and DC converter is there, and then inverter. So sometimes we try to ignore that, battery and then directly inverter, but that is not possible in a practical scenario, because battery voltage is something, and then your inverter input voltage, much more required in terms of DC also, because your voltage for the motor is, rated voltage is required. So that we don't get it, DC in the form of DC from the battery. So definitely you need to require DC converter. Okay. So this is one. And then, you can see that, series hybrid, this is also possible. And then parallel hybrid. So, and then you can see series parallel. So here one observation you can make here. So both are connected here. So both you can see that. Okay. So you have generator and then rectifier. From battery also you can drive, and you have motor also. So two motors are there. And you can see complex, one can build a complex HEV. This is also commercialized by the company. And you can see this rear wheels will run by the, this motor, whereas front, wheels can run by engine as well as another motor also. So this how both can be again interlinked. So this is what one can, think about this kind of complex. Even people are coming with, even Tesla also, they successfully trialed with, they also released with 4 motor. So 4 wheels will have 4 hub motors actually. So that is also possible actually. And you can understand here what is the power flow in the series. Suppose you are driving with the motor with the battery, then so battery will supply this, powertrain. So this is it will come to powertrain, and then this is a transmission system, and then finally it come to vehicle. So this sort the energy flow will be there. And next is battery recharging. That means who will drive the vehicle? So engine will drive. So engine will drive the vehicle, and then engine also can also give a power to the battery for charging. And this is a hybrid drive. So that means engine and battery both will give the supply to the vehicle. This is also possible. So and then regenerative braking. Now in regenerative braking, what will happen is this vehicle kinetic energy will be converted into this this thing transmission system, and this motor will be there. This motor will work as a generator, and through power electronics in a powertrain, so it will store into battery. And similarly, power flow, you can understand parallel system also. So power resistance, that means both engine and then battery will drive your vehicle. So regenerative braking, that means your engine will be off condition. This kinetic energy finally it connected to battery. So that is possible. So battery recharging, that means who will drive the vehicle? So engine will drive the vehicle, but at the same time, engine also will charge your battery. So ZEV, zero emissions, that means engine should be off condition. So battery power will be diverted to your vehicle completely. So conventional vehicle, so that means conventional vehicle scenario, the engine will drive your vehicle, so not the battery. So this how you can understand the power flows will be there in vehicles actually. So one can same thing one can analyze for the combined hybrid vehicles also. And there are some targets also given from government side actually. If you are working with power electronic drive actually for EV, so that efficiency, combined efficiency should be 90%. Motor efficiency plus controller efficiency should be more than 90%. Whereas power electronic converter efficiency obviously 95, more than 95%. Any power electronic what we design for rectifier and inverters, whatever DC, and generally we see that efficiency should be 95%. So same thing also can be applied for EV power electronics. So and if we're trying to take it some ideal traction electric motor for EV application, so then that motor should have these characteristics. Okay, so high efficiency over a wide range of speeds, particularly regenerative braking, and then high torque and high power density, high torque at low speeds, like low speeds when you get starting, accelerating, hill climbing, and then high power at high speeds for cruising, and then wide constant power speed. And this is very popular for electric motor application for EV. And then fast dynamic response and operating in demanding condition like frequent stop and start. Actually, conventional vehicle we don't have any problem. So whenever you want to switch on this vehicle, then you can switch on. So there is no problem actually. Even sometimes you will get a problem that if you don't use the vehicle for a long way, and then things will come into picture like a battery ignition is required something. Okay. And operation should be in harsh condition, you should accept, and intermediate overload capacity. Sometimes hill climbing is there. Ma'am, in that case you need to have kind of power in more than rated power. Then then you can take a support from like maybe super capacitor, ultra capacitor, and then you can give us that kind of surge power also for that particular application. And then low frequency, and then maintenance. This is what generally in conventional vehicle we require. Maybe generally we used to make a service for car 6 months once generally. Is it right? So that kind of low maintenance is required, low service is required. And then it should be robust and robustness, and fault tolerance and safety precautions also should be highlighted for electric drive vehicle. And then low noise and low cost. So generally, this is the characteristics a ideal traction motor should have it. And we can compare the EV drives nowadays actually. So yeah, DC motors we are not preferring now because of lagging characteristics actually when compared with many factors. But in case of induction motor, still it is in race. There's no doubt about it. But at the same time, PMSM, PMBLDC motors, there are many companies, they are adapted easily because more efficiency when compared to them. And because where we can see that induction efficiency is only maybe rated at 3, whereas you'll get a 5 rating actually. Because obviously you have more than 90-95% possible with a PMBLDC. But whereas induction motor is not possible with that. It's touching with 90% also difficult with induction motor. And we can see the different levels of charging available. Level 1, 120, but we don't go with 120 because our power system comes with a 230 voltage single phase, and 3 phase 415 or 400 voltage actually. And then level 3 it goes more than that. So DC fast charging, there's one actually where if you want to have a kind of more power, more than 22 kilowatt, then actually people will go with the DC fast charging. That means you rely on this 3-phase power supply. Mostly in that case we go to charging station where there is a transformer will be there, and through transformer you will try to capture, consume the power actually. So that is more than 22 kilowatt, the DC fast charging. And another is inductive charging, that is wireless. In this wireless, again, two types. One is static and dynamic. So static is when you park the vehicle, so without touching, without having any wire connection, so with the primary circuit to secondary circuit, you can be able to transfer the energy. That technology is also proven. Standards also available. And similarly, wireless power transfer. So when you're trying to make the vehicle and the running, so that time also you can take the power. So even many companies also, they successfully made trials on that actually. So in case of level 1, level in case of available in the market, so people, if you buy a car, so but then they give this kind of 230 voltage in the supply, and then they give one kind of plug socket. So that plug socket is 6 ampere. Then 230 if you multiply 16, so like how much you will get a charge in 3.3 kilowatt. So 3 point, that means if you're charging, connect a vehicle 16 amperes plug with a single phase system, if you consider into single unity power factor, then 3.3 kilowatt average you can try to consume from the grid. So if you're trying to buy some kind of a Tata Tiago vehicle or something, they give the battery power is 20 kilowatt, 19 kilowatt hour battery. That means you need to charge your vehicle so nearly 7 hours time. So 6 to 7 hours time actually you need to wait to get a full charging of the vehicle. So because per hour you are consuming only 3.3, because you have a limitation in a single phase system in your home, only 60 amperes plug is available. We cannot accommodate more than rated actually. And then in that case you should go with the 3-phase system. So 3-phase system, 3 into, then you can multiply 3 into 415. Okay, and then you can go with the 6 amperes plug. Okay, so in nowadays you can see some, they are building new houses, then people will try to put them 3-phase system. Then if you take a 3-phase system into 6 amperes plug, then it will go 7.4 kilowatt. So then that is another charger is available in the market. So then in that case, if you are using 7.4 kilowatt, then actually you will get a Tata Tiago vehicle 3 hours time. So if you, instead of going with 6 amperes, then you go with the 16 amperes plug, then you will get a charging of 20 kilowatt per hour. So that means you will get a charging of 1 hour. So if you go with the 3-phase system, 60 amperes plug, then 20 kilowatt hour you can draw from the grid. So 1 hour is enough to charge your vehicle. But whether do we have the provision in your home? So that is not available. That's why you're going to outside the charging stations actually. That's what we need to improve a lot of electric infrastructure also if we are bringing the electric vehicle. So these are all different challenges actually. Let me discuss many things in further slide. And then this is one of the successful case study, okay, in South Korea. So they launched actually the public transport system with the wireless power transfer actually. They are successfully tried and they are running successfully. Even 2010 itself, they successfully made a trial. So right now they are very good running. And then now you look at the electric vehicle infrastructure, we need to have some kind of intelligent infrastructure, okay, with the support of smart grid. Because it's a one vehicle is not a problem actually. If you are bringing the scenario of thousands of vehicles in the same city, maybe let us assume Hyderabad is there. Suppose by tomorrow you were bringing some kind of 10,000 vehicles of into the market. Okay, people are bought it, and maybe some of the companies like this is taxi agencies or something. And if they bring 10,000 vehicles, then where do you get the charging? Is it right? So that means we need to have some intelligent infrastructure. And we need to make a scheduling of the EV also. This is another topic to discuss, and then people are doing research also, PhDs also. So now actually as an individual also, I want to know where my nearby charging station, and then what is the queue number, how much they charge it. So these are all things also very much needed, for which many startups also coming into the market now. So they are also there in the place now. So they will help you actually. They will connect you to your vehicle to charging station. They will reserve a place, and you need to make a payment through wallet. So a lot of things, a lot of startups also now in the place of this market actually. Even Hyderabad also many startups also there. And we have one campaign is going on, EV30 at the rate of 30. So you can see that by 2030, 30% of the vehicle belongs to the electric vehicle segment. This is what the 8th Clean Energy Ministry has taken this. India also part of it actually. And definitely, as I discussed in the beginning, our operating cost right now with the conventional fuel is very much high. It will come down automatically if you switch over to electric vehicle. And of course, fuel cost also. If you see the fuel cost, maybe petrol cost, people are spending 110 rupees or 115 rupees per liter now. Whereas electricity price is much cheaper than this, fuel or petrol or diesel. So that one has to agree. But there is one disadvantage is the electric vehicle. So battery cost is high. So that we need to agree that at this moment. So it is costing, nearly, 40% actually. 40 to some cases there 40% is guaranteed. So some of the vehicles, it is touching to 50%. 40 to 50% cost, of the vehicle it belongs to again battery only. This is one of the present disadvantage of the electric vehicle. That means people will, when you buy a vehicle, they will give you guarantee that 3 years or 1 year, 2 years or whatever, and this many kilometers, 1 lakh 2 kilometers based on the battery and whichever is earlier. Is it right? Then if you are running with this 1 kilometer or 3 years whatever, and then if you want to replace the battery, then you need to spend 40% of the cost, maybe 10 lakhs vehicle, and then again 4 lakhs you need to invest actually. So are you ready to invest 4 lakhs after 3 years on the car to replace your battery? So these were the current challenge. So for which we're anticipating that battery cost also will come down by next within a decade time, by 2030 something. So for this material science and then MME and then nanotechnology. So these are chemical engineers. They are working hard to come with a lot of new innovations in these battery technologies. And if you see that by 2050, definitely we see a lot of decline in conventional fuel vehicle, and you see good rise in these, plug-in vehicles and the electric vehicle, including fuel cell. Fuel cell also many now. Toyota also have a big plans, to launch, a fuel cell based vehicle. That is also very soon we are going to see in this Indian market also. And we see very good market in the EV, and not only for just for transportation, but we have a lot of employability opportunities also there in the EV sector by 2050. So this is what here scenario, and this is what the scenario. It was started in 2009. Tesla was launched one model, so Roadster, and then it was many companies also there into market this actually. And finally you can see, and also OEM company, many OEM companies, original equipment manufacturing companies of automobile, they announced this particular year we release this many segment of electric vehicles. Suppose BMW, they said 25% by 2025. So GM, they said Honda, they said 15% by 20. That means they are switching over to electric vehicle segment actually. And China, they have very much targets, and Indian targets are like this. So 30% electric car sales by 2030, and 100% battery driven vehicle sales by urban buses by 2030. So that means you can, even before that we can see maybe possible. So maybe in Hyderabad, all the buses, you can assume that all the buses battery driven vehicles by 2030. So that is what many states also they're coming with their own EV charging, EV policies. Even Telangana government also they release it. What is their EV policy? Actually, even Andhra government also they release. So like that, every state they're coming with their own EV policy to encourage, these battery technologies, electric vehicle technologies, their storage. And surprisingly, you will see there are some countries already they announced the ban on IC engine production in their country. Okay, these are the countries. They said this is the year. Ireland, they said by 2030 onward, we'll stop the IC engine production in the country. So like that, India also we had one statement, but that's not official. By 2047, by celebrating of the 100th independence year, maybe India also may ban the IC engine production in the country. So that is not official statement, but it may happen also. Okay. So this is what kind of things will happen in India also. And even similar things also. So this coal-based power generation also India also where I think so 2036 onwards. I think so. Indian government no more new sanctions for coal-based power plants in India like that actually. So because we need to work for this sustainable green technologies in transportation as well power energy sector. And look at some of the initiatives government how they started actually by 2012 actually. Government has started this National Electric Mobility Mission Plan 2020 NEMMP. We have some target they mentioned it, but we could not achieve much of them actually. But it was a very decent start from the Indian government side actually. And then next is we Indian government immediately part of this mission plan. So they started with FAME scheme in 2015 actually. So there is a fast adoption, manufacturing, and hybrid electric vehicle. And first phase was completed in the April 2019 actually. So 4 years time. And then we were completed 2020 with I think the recent June we completed another term also. Now, right now still government is making new plans for that actually. And Niti Aayog they released one guidelines in 2017, and recently 22-24 also they released another report. And 2017, Tata Motors won the first public procurement EV tender. So that is launched by Energy Efficiency Service. This is the company, Energy Efficiency Service Limited. This is a complete responsibility they took to establish the EV charging infrastructure in India. So later, this company has given the decentralized powers delegation to the state government. So state government, they are given to some state, they are given to this. Suppose, for example, in Andhra, so they are given to NetCap, so where the renewable energy agency as well as in power distribution companies. So this is how they have taken the responsibility to establish the EV charging station. And by 2047 onwards, so we let us expect that all vehicles, new vehicles in the sales in the EV segment only in the country. And this website, one should go through it. Actually, it's very interesting website. So FAME India. So right now we are at phase 2. That's what it's completed actually recently. And if you want to purchase any vehicle, 2-wheeler, 3-wheeler, 4-wheeler, so let us see, go to website and then see, you will see the models here. So whatever models are there, so let us buy those models only. Okay. And nowadays many startups also coming into picture. They sometimes they try to buy the components from other import them and then assemble them without any registration. They try to buy, and you will face a lot of consequences, problems and services with them actually. So don't do that. Maybe let us OEM companies, all OEM companies, they are registering with the government as a dealers and then OEM company. So maybe you can look into this website and find out the model, whether it is recognized by registered with model, then only you can purchase. And phase 1 and this one period, so nearly close to 3 lakhs vehicles we have sold in India. So we can see how much of fuel we can save it in those 4 years time in terms of liters actually. So more than like 51 crore. Okay, and then per day we saved that 52,000 liters fuel, we saved it. So this is how we are contributing to nation also. And we can see it FAME 2 actually we crossed more than 6 lakh vehicles are sold. Okay, in case of Telangana, if you look at, they are sold more than 25,000 vehicles, they sold it at 25,000 and all actually. And this is how you can look at the models. So if you make a tab models, and this is the company name, this is a company model, and what is the incentives that you get it, and you can see the model, some details about their company and all, and you can go to their company website for more details. So if it is listed in this website, I think you can go and purchase the vehicle. If it is not listed, so don't prefer that actually. Okay, so that is not registered with the government as a dealer as well as or OEM company. So this is what my personal suggestion. And next is let us go to this one of the website where you will get a complete details. One wanted to know that I wanted to get a more complete knowledge from the government of India, what is going on in this electric vehicle segment. This is one of the best website maintaining with Niti Aayog, that is what EMRIT. So accelerated e-mobility revolution for Indian transportation. So where you can get a lot of updates, government schemes, tools, and then how much of fuel you can save, how much economy you can save in terms of money, where the charging stations, mapping, resources and standards. So all the documents, policies, everything is available here. So this is one of the unique website the government of India developed actually. So one should refer it. Even to go through website and find out, I think it takes a lot of time. And this exercise can be given to your students also. They can explore that more than. And this is a company, I said, so Energy Efficiency Services Limited company. This is a complete responsibility they took actually to establish the charging infrastructure in India actually. And this is the hybrid vehicles you can see in the market. So Toyota Prius, just now I said actually what they go with so parallel hybrid, and then Honda Accord, Toyota Carmi, and then this is next is MG Hector vehicle also available. Is it right? So I think most of you seen. And hybrid, so Maruti Ciaz vehicle, I remember the first vehicle they launched it in a hybrid model actually in India. And then Suzuki Swift, Suzuki Swift is available, Suzuki Ertiga is there. And then Baleno also nowadays available, Glanza is available, Grand Vitara also it's available. And then other luxurious model, Lexus is there, Mahindra Scorpio also it's available, BMW, Volvo XL, and Toyota Innova Hi-Cross also it's available hybrid also nowadays. And coming to electric vehicle, Mahindra E20 is available. And previously, we used to see that this kind of models with Reva, one company in Bangalore base, and later this is similar model. And next is Mahindra E Vitara, and then Tata Tiger EV vehicle. Is it right? So this was the first vehicle launched by the Tata Motors, and then Tata Nexon EV, one of the popular model in the Indian market now, and then Hyundai Kona, and then MG ZS EV. So this was the Corona COVID period, and we have launched, I think, 6 vehicles we have seen. And later, after the COVID, actually, we got this release. Tata Tiago EV is available, Mahindra SCV 400 EV, and then MG Comet EV model, last year model, and then Tata Punch model. I think this year they launched this Tata Punch also. These are all very popular models in Indian market, where they have plants in India and then producing them actually. And charging stations are coming up well in metropolitan cities like New Delhi, Bombay, and these are all cities actually. But slowly their government also trying to find out, highways, and then, second tier 2 cities also. And during COVID itself, one good thing has happened. Government of India established through ESL. So India's first public, EV charging plaza in New Delhi. So that was launched in July 2020. And at this charging point, actually, you can try to establish 5 charging vehicles, and you can charge, 45 to 90 minutes based on type, and then 10 rupees per unit they are charging, and you will get yearly 1 rupee 25 paisa per running cost actually. And these were the charging station maintaining by ESL. And nowadays you can find out any state, Hyderabad, whatever. Now you can put the Google also charging station. This how you can get a map also. And many private companies like Tata Power, many others also, they maintain this kind wherever the parking places are there. Even I think Hyderabad, I think most of you are aware of Begumpeta, you can find. This is what you will, you see them from long ago. Is it right? So this is what I have seen even 5 years ago itself actually. So now success of EV charging, it depends on 3 parameters mainly. One is accessibility, utilization, cost. Okay, then only we can define whether the charging station in the successful path or not. And this was the, 4 years ago they sanctioned, this is a charging station. Okay, so for so Andhra they sanctioned 433, and then Karnataka 126 and all by ESL. Totally around 1,000 they sanctioned it. So overall under FAME 2, 2,636. But most of them, installed. But there are some states still there in installing stage actually. So like that actually. Okay. So it's in some states very slow pace is going on. So whereas in the Andhra Pradesh state, they have chosen 4 states: Vijayawada, Visakhapatnam, Tirupati, Kakinada, whereas Telangana, Hyderabad, Warangal, and Karimnagar. So this is what the government has. Even interestingly, you see, so NTPC also into this EV charging infrastructure business actually. So NTPC already they entered into solar long back, and now they are entering into EV charging stations also. So this is how the many companies also they are into path now. And overall roadmap is that we need to bring this 50% of the light duty vehicles by 2050. Earlier we were talking about 30%. Now by 2050, 50%. Let's see how we can improvise the scenario. And you can see that many professional societies like including IEEE, they are working towards they launched new vehicular technology society. They are contributing this transportation electrification community and all. And one interesting problem to us actually, what is the impact on electric vehicles and peak demand? Okay, so already in conventional scenario we addressed it. So like industries are there, agriculture sector is there. So now we tried to do, government has given scheduling them, and then properly they made a guidelines, and then different connections through transformers. Everything is better. Even suppose the agriculture sector, government is advising to make a separate connection through transformer, and for whatever reactive power required for the motors, you are responsibility to connect to the capacitors. Not from, you should not draw from the grid. Is it right? And also they give dedicated 6 hours time, 8 hours time, 10 hours time, like that. And that way, they do the scheduling actually. But in case of an electric vehicle, that kind of scheduling also it's required, much required in the future scenario. This is what scheduling of the EV is another hot topic. And IEEE Smart Grid initiative is also this wireless power transfer, and then EV vehicle segment also taken priority actually. And look at this is some of the private players, including Tata Power. Actually, they are into this EV charging solution, and you can find the maps like this where you can put the charger location in city. So like this, for example, you put the Telangana and Hyderabad, you will find this kind of charging station locations and all. So they'll give all the these are some of the maintained by government, some of the private partners and all. So this is how you will get it. And government, they said 22,000 EV chargers, like 3 kilometers grid, they will establish 1 charging station. Highways 25 kilometers on both sides, 1 charging station. And then next is 3 kilometers radius, 1 charging station. And of course, if you want to set up, charging station in India, it takes cost. Actually, it knows a lot of things. Okay, one is, you need to first cost is, major cost, electricity connection cost. You need to approach the distribution company. So maybe in Andhra, like in Eastern distribution, Southern distribution, and then this way. And you need to approach them and then make a connection with the transformer, all these things, and civil works and EV management software also required, and integration with this, vehicles and other, and technician, manpower, advertisement, land lease. Okay, because you need to take the land on the highway side or something like, because that is also cost. So these are all the different costs involved when you're trying to establish the charging station. And there are some startups also coming the picture that they will help you in the charging platform. So like one of the company like Static, where they promote this, EV. I mean, they will connect with your car with EV charging station infrastructure or something. And then now look at this, public charging infrastructure requirement as released by Government of India from the Ministry of Power actually. So what they said is, if you want to charger type is fast, then your combined, charging system is there. Okay, then you should go with these are the voltage, output voltage 200 to 750 and all. In this case, so Chomodo, that is, 250, 200 to 500, and it is meant for four-wheeler. But in case of type 2 AC system, minimum is 22 kilowatt, where you go with a three-phase system, and then a 16 amperes plug, then you will get a 22 kilowatts, sorry. And that is meant for four-wheeler, three-wheeler, two-wheeler. And similarly, slow charges, we go with the Bharat DC, Bharat AC. And these are the voltages, you need to maintain that 48, 72, 230 respectively. And finally, these are the wheels, four-wheeler, three-wheeler and all actually. And of course, parallelly, next as a year, Niti Aayog also released it. So in case of battery capacity for two-wheeler, 3.3 kilo maximum. But actually now we look at in the market, so there are some two-wheeler companies, they already crossed 4 kilowatt. Okay, so these are the battery capacities, these can be amended and then improved also. Is it right? So based on the need and that. So these are the typical standards the Government of India given to us actually. And we need to maintain battery voltage 48, 72. And in case of, we look at the buses and trucks, battery voltage is no more, less than 500. It will be more than 1000 also. So that is also possible actually. And this is the normal charging. So it is declared from, less than 22 kilowatt. If you are going with more than 22 kilowatt, then you go with definitely high power charging, that is DC fast charging. You draw directly three-phase power supply from the grid and then convert into that AC to DC. Okay. And then, these are the charging, types you see in the market. Okay, these are right, EV charger. These are called, EVSV, electric vehicle supply equipment. And sometimes, you will be misunderstand that, so, supply equipment, EVSV, will convert AC to DC. But it's no, actually, it is, just, it's AC to AC only. But, that AC to DC conversion will happen inside the vehicle. So this is just EVSV, and it never converts anything, DC actually here. So it's similar to your stabilizer. I think you have the stabilizer for your, appliances like air conditioner, similar to that. Because this is much required, so to find out the faults with the line, okay, supply system. At the same time, it will calculate what is the amount of energy that you drawn from the grid. So one has to calculate that voltage and current, and then power factor. And then you need to, that information should be given to microcontroller. Microcontroller will make that, calculation. And finally, the bill will arise. Is it right? So these are all things will happen. And this box is only meant for AC to AC only. And we can also integrate with solar panel and the net metering system. Obviously, when you go with, grid connection and then, solar, net metering system is necessary. And another technology is coming up, battery swapping technology. Even Indian also made successful trial with this actually. So now we can replace your battery, just go on them, don't wait for charging and up. So put your battery, old battery, and then get the charged battery and take it away. But there are some advantages and disadvantages. Barriers are there. Don't say disadvantage. Barriers are there. Challenging tasks are there. So lack of standardization, and then battery aging, and then high cost, and all these things are there actually. So maybe that we need to overcome these all challenges actually. And Niti Aayog also given a lot of encouragement in terms of lot of push to automobile companies. And each government state they have given different tariffs. So look at Andhra, they said 6.77 rupees, and look at maybe Telangana 6 rupees per kilowatt actually. And it depends on again demand charge, whether it's low tension or high tension. But actually this is what they said they will take from the this EV charging owner actually. But actually the same cannot be charged from the EV charging user, is it right? EV electric vehicle user, because again profit is there. Maybe if you take 6 rupees something they pay to the government, but they may sell to 15 rupees or 20 rupees per unit actually. Okay, so where the remaining will go to profit as well as payback for their EV charging establishment. And this is what some 2 years ago, one fellow who bought the first Tata Nexon EV vehicle, then battery cost was 7 lakhs, whereas vehicle cost is 12 lakhs, battery cost is 7 lakhs. These are the kind of scenarios will come into picture in this future. And if you buy the electric vehicle, so we need to come up with a new solution to how to reduce the battery cost. And right now we have very much simple procedure is that anybody can establish a EV charging station. In case of if you want to establish a private petrol bunk or diesel bunk, whatever, gasoline, gasoline station, there are a lot of permissions required. We need to apply for agency and all. But in case of EV charging in this thing, I think is very much simpler as of now actually. In future, but the government will put a lot of restrictions. They will put a lot of regulations also. Right now, anybody can establish. Let us government also bring the agreement. This is the agreement format actually. I'm just showing you first page only. So let us make agreement with land holding agency, then your company, and then take a connection, go to distribution company, get the connection and establish everything. You can launch your business. So there's no much regulation, nothing. You need to get a connection from the distribution company, that's it, because you are drawing power from the grid. And we have Indian standards also there. So there's a BAS actually. So these are directly we adapted from the IEC. Most of them from adapted from IEC. Okay, and these are we convert them into Indians. This thing, and then we made it available for 7 kilowatt. This is a standard actually, IS standard in it. And this is a DC charge point actually. This is a AC charge point. And you can see the standards also we need to follow for not only for electrical flow but communication also, plugs and then inlet and outlet also. So these are all. And also primarily this is a very good standard for all of us actually. IEC 61851-1. So that is what I to play. Electric vehicle conductive charging is general requirements. Even any company, okay, any company if you want to establish EV charging, so they should follow. They should 100% compliance with this IEC standard. And this is another one 21.2. So this is the electric vehicle requirement connection, AC DC supply, and then EMC requirements also. Even we have one startup actually, we followed these IEC standards and then we made the compliance with this actually. And if you want to launch your electric vehicle and chargers into the market, and we need to get a certification that whether your charges in compliance with these IEC standards or not, then only you are permitted to launch your charges in the market. Okay, so that's why standards are very much important. And then this is inlet and outlets. Okay, so these are standards 62196-1 IEC from IEC. And we have communication protocols standards also there from SA International. So that is what Smart Energy Profile 2.0 is there from US standards also available. And we can find the standard details also from EMRIT website, where we can see that BAS actually. So where we adapted from IEC actually, and then we renamed it actually, so that we can see that. And we have in India, how they adapted and all. So we have Automotive Research Association of India is there, and we have a committee also. They try to see that what kind of standard from internationally we need to adapt from Indian scenario. So they did this work actually. So IEC standards and all. So they try to adapt this 1 and 21, 23. So this is meant for 23 exclusive for DC fast charging, and these are requirements for digital communication between EV charging station and vehicle actually for DC charging system. So the standard you need to follow. And we have the pictures also how where we connect with this. And as per the standards only we need to keep this all the charging and where to place the battery and all. So that way automobile companies also they follow the standards actually. And this is a typical diagram you can see power flow. We have a AC power supply and transformer. And then DC grid is there. Converter is there, and then battery pack, and then vehicle control unit. Because vehicle control unit also requires some kind of auxiliary power supply, so that you can take from the from this supply also. Okay. So then next is yeah, we have the voltages like this. Higher voltages for buses and lower voltages for other passenger vehicle. And this is a DC charging system actually, where you can see that here EV's battery is inside the vehicle. Okay, battery is inside. You can see this DC charging is outside the vehicle. Okay, that means it's off-board charger. So you can take the AC and you have a primary rectification here, and power factor connection you do at the beginning, and then you will get a non-regulated DC. That non-regulated
Sir,
AC to DC. So most of the cases, you see this kind of vehicles in the market actually. And some of the vehicles now you can see here. So another is battery is only inside the vehicle and DC to DC charger, but where you give the isolation at the beginning. Okay, and then you do the secondary rectification with the smoothing, but still you will get a non-regulated DC that you regulate using DC converter. But total this charging system outside the vehicle, again this is a off-board system. And this is also why we should rely on the AC supply. And then if you have any kind of DC main supply from solar or something, directly you can use the DC and then convert into DC we regulate it and then give it to battery. And digital communication and AC. These are the AC standards also required, 21, 22, just now I said. And other environmental testing procedures, voltage bands and EMI issues, electromagnetic compatibility, all these things, the standards we need to follow. So all the automobile companies, EV standards, ideally we should follow these standards and make a compliance, and then only we should release to market. And this is another communication protocol we get from SAE. J28447-1 is very popular standard for communication. And based on the standards only we go with this. If it is AC slow charger, and then EV SV to EV, that cable you need to give B cable. If it is slow fast charger, and then you go with a D cable. So this is the nomenclature also given for cables based on the slow and fast charger. Where do you connect them? And then these standards are already available, and China government also they made it in America. And then we have Indians, we have BAS standards we made it. And these are battery pack. Even battery packs also they have standards. Okay, and surprisingly you see that wireless charging standards also available. IEC they made it wireless power. That means if the standards are made, that means technologies are proven, and somewhere directly we can adapt the standards and then execute the work and then launch it to market. So that's what the indication is, it right? So this is what wireless power transfer charging. Standards also available to us. And workflow, you can see what is charging flow. So now we can see this level 1, level 2. So you have a grid supply and then EVSV. So that's what I mentioned. This is what the EVSV, the electric vehicle supply equipment. And you have onboard charger will be there inside the vehicle that will convert AC to DC and then give it to battery. So this is what inside the vehicle. So for level 1, level 2 inside the vehicle, this is onboard charge. But whereas you can see DC fast charging. So you have AC to DC conversion will happen outside the vehicle. And then you have a provision to the given to AC to DC converter, or you can go directly to DC and then battery. So this is a conversion will be there, universal converter will be there. So that comes in a level 3 charger. And yeah, so one topic is interesting. Sometimes vehicle to people are talking about vehicle to grid. So how the vehicle power can be fed back to the grid. So what is the necessity? Why I should send back to the grid? In case of tomorrow in some kind of scenario we may come due to dynamic pricing and then smart grid, and where if you don't use a vehicle, we use a vehicle, so you can supply back to energy to the grid. So that means maybe that is a peak hour is there and then a lot of demand for electricity. You can sell power to the grid and you can earn money also. So and that is maybe if an individual may not be that much profitable. Let us assume there are some case of 1,000 vehicles are there which are not used in currently, maybe night time or something. Then you can pump. So this kind of scenarios are also available. And then this is what the levels EV charging actually. Okay, that's what I was talking about. 3 kilowatt. If you go with the 3-phase and then 6 amperes plug, then you will go with the maximum 22 kilowatt, 20 kilowatt. Okay, and if you go beyond that, then you should go with the fast charging DC fast charging that will convert DC AC to DC using the with the transformer connection. And these are different types. Okay, level 1, level 2, SA-J1722, you should use it. And then combined one, CCS is good. So level 3 charger, and somewhat also can be used for cheap, but we don't use them. But we use, CCS charger, we use them actually. And this is what is there. Okay, so whatever you see the charger. Okay, I think most of you see the electric vehicle charger outside for a 2-wheeler, 4-wheeler. And this is what the inside, what is there inside the box. This will happen. This is a block diagram of the inside the component, and we see that this line, single phase line, and these are directly your cable for connection to vehicle. So okay, you can see here. So AC to DC will never happen here. So just AC to AC only. Okay, but what do? We put a current sensor, voltage sensor, and for which we will try to measurement the power what we consume from the grid. And at the same time, this microcontroller should work. So it requires some power. Again, we will have take the power from the input, and then they step down the voltage and they make a regulation, and then give the auxiliary power supplies for various components in the charger, and then that's how to do that. And this is the microcontroller you have it actually. And this microcontroller will ensure that whether your gun, cable gun is connected properly or not, for which you will try to build a circuit called pilot signal circuit. Okay, and there is IEC standard is there. We need to maintain voltage with in terms of PWM pulse and square waveform, and through that actually we'll try to identify that whether your gun is properly connected to vehicle or not. Okay, as per the IEC standard. So this is how you need to do that. And finally, at the end, on the top, we see that some kind of communication where that can be linked to your mobile phone, web app, or even some kind of HMI display system, smart, some kind of touchpad. Okay, that is human interface in machine will be there, where you can be using touchpad, so you can control your things in the charging EVSV also. So this is what you see inside the box. And similarly, DC charging station also same thing. Okay, so you have this power module, so sensors and directly, and then you have DSP microcontroller is there and all these things. Okay, so these are all things available. And okay, and now we will discuss something about BMS. Actually, this is also interesting to us. So vehicle to grid and beyond. So batteries, actually we should have some kind of silent feature for traction batteries actually. So high energy density, and then a long life and wide accepted recycling and so as I mentioned earlier also, battery technology is improving, and right now we are with a lithium ion battery. We have a lot of advantage, and then lithium polymer batteries. Now with mobile phones, lithium polymer battery is very successful because we have a lot of good characteristic for that particular application. And then lithium, people are talking about lithium sulfur, lithium sodium batteries actually. So for EV vehicles, so these are all new technologies coming up, and you can see that lithium ion has more specific energy, specific power. That's why we are using lithium ion battery. And even if we compare with the lead acid conventional batteries and nickel metal batteries, it has a lot of advantage in terms of not only efficiency and self discharge rates, durability, and many things. Is it right? That's why we are going with lithium ion battery. And generally, so what we expect battery life, maybe 10 years. People are talking about 2 years or 3 years. Is it right? So based on our promised driving cycle, but actually we expect that at least 10 years, because vehicle generally, if you purchase vehicle, we see that vehicle life should be maybe 20 years, even 2-wheeler or 4-wheeler. So at least your battery service should be 10 years off of the vehicle life. Okay, that's what we should expect. Okay, with that, what we should required from the market actually. And also we should cut the battery cost significantly. Right now it's a 40% is there. We should come down it's as early as possible. And you see the causes of battery failures. Yes, actually it's happening, unfortunate. So due to a lot of external factors and human factors and battery facts, short circuit, fire caught, short circuit while charging and overcharging, everything. So now, you see this kind of news also. People are injured and killed, electric vehicle, 2-wheeler, and most of the cases with 2-wheeler only. And government also given a lot of warnings. And then some of the companies, 2 years ago they recalled the many units. Okay, they again replace a new one or something like. So these were the things happening every year actually. But right now it's reducing. Okay. And we need to understand what are the factors affecting the battery efficiency. So frequent charge and discharge, and then next is what is the current of charge current that you are flowing into the battery, and then what is the discharge rate, and then self discharge, dead period, and temperature. All these things are matter actually. And also sometimes then you need to understand what is the battery operating conditions also. Okay. And also sometimes problems will come with excessive battery charging. Sometimes problems will come with inadequate battery charging. I think sometimes personally we experience with the laptops and mobile. So if you go with excessive battery charging, if you go with inadequate battery charging, similarly same things will happen with the battery, EV batteries also. And storage conditions, we don't have any much problem, but our environment is good actually. And in case of we can also one can come with hybrid energy storage systems actually, where with battery can be connected with a motor drive parallel with ultra capacitor. And then where you have a DC converter where the battery voltage and ultra capacitor are different. That's why DC converter. And this diode is unidirectional power flow. And you can see the replacement of the battery and ultra capacitor is different. Where this ultra capacitor battery is parallel operation. This is where whichever you wanted to make it. And BMS is one interesting area for all the EV charging infrastructure is connected directly, where we can try to sense the parameters of voltage, current, and temperature. Okay, in internal temperature of the battery along with the ambient temperature during charging and discharge. And we try to see that these are objectives should be met through BMS. One is protection of battery cells from abuse and damage, and extend of the battery life as long as possible. Make sure that your battery is ready to start whenever you want it to make it. And these are the functions of the BMS: charging control, discharging, SOC, SOH, and then cell balancing, thermal, data acquisition. And also logbook also required, because when you make the service, we need to see what is the past history of your service and safety production. And we can make the arrangement of BMS. Okay, so three: one is distributed, modular, and centralized. And you can see they're distributed, how the cells are made, and each has a source of energy, and we have one master control. So, but you have the many number of sources are there, many printed circuit boards are there, many slaves are required. This is disadvantage. We can reduce the slaves and make a modular. This is one modular, and this is the second one. So, in case of heavy duty vehicles, they will come with this. Maybe this model is 20 kilowatt, and this is another 20 kilowatt. So, master control will have for total one. Actually, this is how modular things will come for heavy duty vehicles. And this is a centralized one, centralized topology, where you can accommodate the battery cells, and then you can make the one master control. And this is how BMS will work. So voltage, current, and temperature, you will give to microcontroller data. Data is nothing but microcontroller, and you will try to estimate the state. Okay, the state determination, nothing but your SOC and SOH. That information will be given to user. So user will decide. So my SOC battery is only 30%. Then he will decide to go for charging. And some of the things can be automatic actually, where this information can be given to electrical control system, that immediately it will convert, switch over your cooling system of the battery with air or coolant. So that's how we can make some automatic actions also. So this is it. And then we have in BMS both components, software is required, hardware. So in case of hardware, so your circuit, safety circuit, sensors, data acquisition, microcontroller, charge controller, your DC converter, communication components, okay, devices, thermal management, coolant, fans, or something. These are all hardware components. But for which this SOC, SOH, cell balancing, all this, we need to write a programming algorithm. So which comes under software part. And this algorithm. Now people are applying for SOC, machine learning algorithms for the BMS also. So whatever conventional algorithm, so here also you can apply them. So this is one trending research for us actually. So machine learning application for BMS. And SOC simply you can define like this. So the ratio of currently available capacity to the maximum capacity. Okay, so that's what it is called SOC actually. Okay, vary. Okay, that you should remember. Okay, so this is like your mobile phone. In mobile phone, you see that my mobile is 70. That means this is the same, like, okay, you are comparing to the maximum capacity. Okay, in the SOC we have methods are there: Coulomb compound, Kalman filter, and then extend Kalman filter, and then machine learning methods also you can use them. And now coming to SOH, so we need to compare battery performance with a fresh battery always. Is it right? Because always it's very much required. Okay, so where SOH this is a capacity estimated time t, and then where C0 is new battery. Okay, so that means this way, using this you will try to find out what is the health of the battery. So state of life also you can estimate, so that you will get that this particular driving cycle. So after a few days, maybe after 15 days, I need to replace my battery. Okay, why these all, SOH and SOH is required mean, so batteries are not so if you know this SOH and SOL for the user, then you can make a place order. It will take time and you will get it on timely. So before batteries, I mean cycles are over. Okay, and for which you will try to find out this from with SOL. What is the remaining useful life of the battery from SOH actually? So these are all part of BMS actually, and BMS and V2G. I was given one example previous. And you can see one real life one example. So in 2011 there was a earthquake is happened in Japan, so where one Nissan vehicle, Nissan Leaf is there, that the EV model name actually. So 66 vehicles, they tried to give the power back to the grid as to grid stabilized actually. Okay, this guy, even in UK also one case study was told, so drivers are pumping energy back to the grid whenever they don't use it, they are earning money also. So this is how the things will happen. So we know that unidirectional charging that we take from our power from the grid, and V2G is we give power to the grid. And now another real example, vehicle to home or vehicle to building. That means in the future you can think real example like vehicle will systems. So your home EPS system is there, battery and then inverter is there, and people now solar system also, solar battery UPS system is there. Now you can replace that. So your car battery will give a power to this. And even for building also, even now for emergency power supplies, people are using like diesel generators or something if any function is going on, power off something like. But your car can give a power to the kind of this thing actually. Just a second. Okay. Okay. Yeah. So yeah. So okay. So let me come to architecture actually. So architecture of the smart charging management system. So yeah, I'm coming to end of my presentation. Let me give 5 minutes. By 9 I will end it. Okay. Yeah. So now we have let us assume that many charging stations are there. So how do you maintain them? How do you connect to the grid? So this how in future with the help of smart grid. So we need to have a smart charging management system, and we have open source charge point protocol is there. So even now this protocol is open source. Anybody can build it. Even I have given one BTech project also for student. They have done it with AWS actually. So they have written good code for this where this open charge protocol will help us to link with the EVSV and your vehicle actually. And one can build hybrid also. And then if you deal with this, definitely cyber security is one. We have cyber security reports also there, guidelines also there. And then big companies like even Honda and GM also, they had joined the hands, and then they come up with a lot of smart grid interoperability for EV solution. These are all big different companies, they work towards V2X. So V2X means vehicle to anything. We can connect it to and this vehicle energy to anything actually. And government gives a lot of employability opportunities, is it right? Even if you search in a keyword electric vehicle in Naukri or wherever, government also given a lot of employment trainings and all. And this is one of the interesting for you maybe. So this one paper, you will find 2000 plus papers or literature survey. These are all different areas directly connected to EVs. Okay, this is very interesting paper. Maybe you can note down and then download them. And this is sometimes you can make a case study also. You have a source of energy, solar, wind, and then battery is there. And you have different charging stations are come, EV vehicles are come. These are chargers actually. Now you need to work with algorithm that so where do I need to take power from the solar or battery and then grid, so which is economical. Then you can make a flow chart, is it right? And then you can make a condition like whether you want fast charging, slow charging, average mode, and you can make a build algorithm also. So like in between you can switch over to fast mode to slow mode to fast mode. That is also possible. Okay, generally so if you make fast mode, generally price will be more. Slow charger for cost will be less. Okay, of course we can bring the IoT applications here. This is what the broad application IoT on power system actually. This is the topic, different topic. I will generally I need to discuss separately, but I'm showing here. So blockchain, of course, peer-to-peer energy trading also will happen. So in this, electric vehicle also going to play a good role actually. So peer-to-peer energy trading, and cyber physical systems is one of the good area now coming up well. And this is directly linked with the electric vehicles now. So where you have social layer, we can model this EV charging owner with charging and discharging, and then aggregator will model with the physical layer, and then cyber layer control center actually. So now we can make a cyber physical system application for electric vehicle charging application. This is what the new, trending areas also coming up. So we know power system and then smart grid application now coming into slowly with the smart grid application. Now in future we are going to see cyber physical system in energy, cyber system, social system energy also. This is how our power system is going to evolve. Now people are talking like maybe electrical engineering 2.0 or something like, but it's going to be beyond that in the future. And technologies are going to be synergies. Okay, don't think that only electrical technology. It's complete interdisciplinary. So we are also, as electrical engineers, we are also dealing with the data communication and data information communication actually. And these are the challenges and directions for EV sector. One is specially designed electric motors. We are importing these technologies from mostly other countries actually. This motor technology that we should avoid. Multi-level inverters. Okay, one can work with the different topologies and control algorithm. And parallel inverters and redundant. If one fails, because safety and then reliability is very, very much important in the EV vehicle. Then you can work with parallel inverters and redundant inverters. And then hybrid source and management. So already we discussed more than one source. Then you can make a management. And then new next generation batteries, BMS, and then EV infrastructure, again static, dynamic, wireless, and renewable energy based charging system. Now people are talking solar based, but solar may not give the full power to the motor, but you need to take a lot of charging and then store and then use them actually. And then vehicle to grid, vehicle takes, and integration with the distribution generation or microgrids with including optimization, and then demand response and transactive energy systems where it involves economics actually, and smart charging management systems, and cyber physical system based solution. So these are all different trending, these are all different trending areas and primary now areas for the research, EV research area for academic. And power electronics, yes, we have evergreen area for power electronics, many sectors. And primarily we work with power electronics, power quality, complexity reduction, efficiency, and multi-port converters, hybrid and parallel operation dynamic, and emerging power semiconductors, novel algorithms, hybrid algorithms. Now people are also coming with smart power models, which the controls, the IGBT MOSFET can be able to connect with IoT and machine learning. This is what we are also doing it actually. And in future, beyond solar vehicle, we can also think about these vehicles, hydrogen vehicles, solar vehicles, all electric. Even one of the successful case studies there, they made a trial also with 10-seater vehicle also, and autonomous vehicle flying, virtual cars and fly. Even there are two companies there actually. So they are selling the flying cars actually. So these are all different technologies in beyond the electric vehicle. And I advise the students particularly, you should learn Python. Actually, industry is going with Python. And of the faculty, where faculty generally focus on this paper publication, funded projects, IPRs, and startups and consultancy. And this is what execution. I just keep them. And these are the areas for projects for students and faculty. Okay. And these are different trends. How do you execute the project? Okay, somebody can do the project only through modeling. I will public IEEE transaction. This is possible. Okay, somebody can work only control technique. Somebody can work only optimization technique. Somebody will work only comparative studies. This is how trending, research. This is what research methodology. Actually, this is again different topic to discuss in lengthy, more than one day. And then these are engineering steps anyway. And tips. Some tips for faculty, literature survey. Sometimes we will try to tell literature may not be possible. This we need a subscript, but we can depend on open source. That is enough. And then you need to be people careful, choose a mentor, go with no experiment and minimal work, and execute the work with open source tools, and publish in only Opus, and then publish with IEEE. You will get a more citation when compared to other conference. And you can use the open source tools because these are free to use, free to share, free to change, and free to sell your work also. And if you want to become extraordinary, definitely you need to go with out of box thinking for problem solving skill. Then only people will elevate you to different positions and that. And three important learnings are important. One is continuous learning. Otherwise, people will be outdated, whether it is a student or teacher or engineer. And self-learning. So once you complete the graduation, nobody will be there to teach you. So everything goes with a self-learning process. And global learning. Whatever you pick from global or whatever you deliver it, that is connected to global direct. And this is what industry trends will go. So for example, industry power supplies. And these are DC, EV charges you go. I'm explaining one case study here. If you want to design mobile power supply, so first thing is any power system, you need to understand what is the relation between input and output. So complete block diagram with a closed loop, you need to come with that. So once you do that, then go with the schematic. So each and pin, each component, so we need to analyze and then fix it. So you need to have a justification. Suppose I'm fixing this, 1 ampere, 1 millihenry, inductor here. So why I have chosen that? What is the calculation for that? So I use one kind of, this company microcontroller. Then why use this, IC? Is it right? So this way, this schematic will build. So once you have a schematic, we have some softwares also there. Then you can try to simulate them and then see that your desired output is get. And then go to this final schematic, you try to design this thing, and you can freeze your design with these design sheets, and then you can also patent them, your design. And then this design can be sent to PCB design software. You can make PCB design, and then finally you can print this PCB board and so component. And this prototype you can test for testing. There are certification agencies also there, and they will test your prototype whether they are done as per the standards or not. Once you get the certification, then your prototype is successful, and then you can scale up, and then you can make a nice, casing or something. You can sell the market. So generally, this is what you do here. And if you have any startup idea, I think you can connect with me. I have one startup where I launched it actually. So where I am a founder, and if anybody, students and faculty, if you have towards startup with idea, without idea, even if you are very much interested without idea, still you can contact with me. I will help you to launch your startup and all, assist you. And because government is given, promoting the startup culture ecosystem, and both students and faculty in all the education, any college, anybody, if you want any help, and I'm happy to help them actually at institute level as individual level. And finally, this is my last slide. Opportunity types. So first one, opportunity will come and knock your door. Is it right? So but actually sometimes we neglect them actually. So maybe sometimes students also, they don't care the opportunity what they receive. Sometimes this opportunity may come directly or indirectly. Is it right? So that you should not neglect them. You should open the door and judge whether it is required. If then you should grab them. Second type, you need to search a long way and get the opportunity. Is it right? Maybe you will spend time, you will work hard, all these things are required. And third one, sometimes call for opportunity to come forward and apply. Because many times, even job also, it's not, nobody will come to your door and give the job. We need to come forward and apply. That's what, students mainly, you should focus this coming forward and then participate and apply. And fourth one, plenty of opportunities around you always, but those are invisible. But your duty, you should identify and grab them. Suppose sometimes, the students will say that I wanted to connect with some machine learning expert to my project. They may think that in our own EEE department, they are not expert, nobody working on machine learning. But there are faculty are there, they don't know, because nobody will keep this some nameplate or something, I'm a machine learning expert on the out of the door or something. Is it right? Their duty to identify and connect with them. Is it right? Some are invisible, but your duty to make it visible and then connect them. And last one is sometimes call for opportunity. First come first service based, because limited seats, maybe like a bus, so train, okay, even food, guest house, whatever it is it right? Seats are limited. So always, first come. Don't wait for like, so last day, last minute or something. So let us make, first come first service based. I think you can grab the opportunity as well. Okay. So with this, I will conclude my talk. So if you want any very kind of interaction, maybe you can write to me. So this is my email ID, and my phone number is, 88. You can find it in my website and Google also. My phone number is here. Yeah. So thank you very much for giving this opportunity. I hope you enjoyed it. Maybe you can give me the feedback. If any repeated content is there when compared to previous week, you can let me know. So not a problem. I'm happy to listen any feedback if at all if you're there now.
Thank you, sir. It is very interesting, sir, actually. Interesting, innovative. But due to time constraint only, okay. With the faculty and management supports, we will arrange one more day, a special. We'll invite you as a lecture. This is the time for participant side. Missionary?
Sir, excellent, sir.
Yeah, thank you, sir. Thank you.
Sir, very informative PPT. Literally, lot much new things I've learned. So thank you so much.
Yeah, thank you, madam. Thank you.
Okay, thank you.
So really
participants.
very excellent,
Due to
sir.
time-
We have covered all the topics related to the electric vehicles. It's really very good information
Yeah,
for
thank you.
in all the aspects.
Okay, everybody, now we have the time to enter the vote of thanks. Now,
1 minute, sir.
one minute.
Nitin
Tell me, sir.
Combly raised the hand.
Okay.
Yes, sir.
Sir, actually, I'm from Ajinkye DY Patil University, Loga, Pune.
Good, sir. Please.
Okay. Pune Municipal Corporation, near about 300 electrical vehicles are running on a road.
Good, sir.
And due to that, reduction of 9% CO2. That's a better improvement. But there is no any state level data collection regarding to that.
Oh, super.
So regarding to that, all state transport and other corporation, if you get some collective data, then we can increase too much enhancement and confident that we can use that electric vehicles, and we are too much proudly say that we are too much upgrading ourselves regarding to electrical vehicles.
Okay, okay.
Thank you, sir.
Good, sir. Good, good. Speakers had phone number as well as email ID in chat box. Any doubts, any queries in future, you can contact sir.
Yeah. And
email.
share the phone number as well.
Yes,
As,
sir.
okay.
Hello, sir.
Yes, sir. Yeah.
Sir, so organization.
Yes, sir. Shall we go for vote of thanks?
Okay. Sir. So this is the time to vote of thanks. Let I invite Mrs. Vanitha Garu to give the vote of thanks.
Okay, sir. Thank you for giving this opportunity. Good evening, everyone. I'm Vanitha from EEE Department. It is my privilege and honor to deliver the vote of thanks for this enlightening FDP program on battery charging technology for EV vehicles. I would like to extend our heartfelt gratitude to our speaker, Dr. V. Sandeep Garu, for their inspiring and thought-provoking sessions. Your expertise and insight have provided us with a deep understanding of battery technology and electric vehicles play in a shaping and sustainable future. To our participants, your active engagement have been remarkable throughout the program. Your insightful questions and discussions have truly made this FDP dynamic and meaningful. Once again, thank you all for your presence, participation, and contribution. Let us continue to work together towards a greener and more sustainable future. Thank you, sir. Thank you for giving this opportunity. Thank you, Sandeep, sir.
Thank you, madam. Thank you. Thank you very much.
Thank you, ma'am.
Thank you, sir.
Sir, thank you, sir. Sandeep, sir.
Yeah, thank
Please.
you. Thank you.
Okay, please leave. No.
Okay.
So, dear participants, so successfully we completed 5 days. Tomorrow we are entering into 6th day.